Welcome, and thank you for joining today's session, How Vanguard and Bloomberg Use AWS PrivateLink. My name is Ilya Epstein, and I'm a Principal Solutions Architect with AWS. I've been with AWS for 3.5 years, working primarily with financial services organizations. I'm joined by Barry Sheward from Vanguard, who is a Chief Enterprise Architect there, and Corey Albert, who is the Head of Global Cloud Strategy at Bloomberg. Before we get started, I just want to ask a few questions. How many of you are familiar with PrivateLink? Awesome. How many of you are using PrivateLink today? Okay. How many of you are using PrivateLink for non-AWS services? Much less. Okay. And one last question. How many of you would consider yourselves to be a service provider of some sort, whether internal or external customers? Awesome. So I think this is the right session for you. I'm really excited about PrivateLink because I think it's one of the most innovative networking services that we've launched over the last year. Not only because it allows AWS to deliver services in a new way, but it allows you as customers to use the same scalable and highly available technology to deliver your services to your customers. So let's get started. First, I'm going to do an overview of AWS PrivateLink, and I'm going to go deep in the technology and how it works. Then Barry's going to talk about Vanguard's strategy in terms of micro accounts and how PrivateLink was an enabler in that strategy. And then Corey's going to talk about how Bloomberg is using PrivateLink to enable delivery of one of their flagship products called bpipe. I want to give you a little bit of an overview of AWS networking, but this is a 300-level session, so I'm going to go relatively quickly through this, but just want to make sure we're all on the same page. So with AWS, of course, everything starts with an AWS region. A region is a geographical location around the world where we offer AWS services. We have 19 regions around the world, unless they announce a new one today. Within a region, you could deploy a VPC. A VPC is your isolated portion of the AWS cloud. You define your own CIDR range, and you have full networking controls of resources inside VPC. You could control routing, NACLs, and security groups. Now, of course, an AWS region is not a single data center. Within an AWS region, we usually have at least 2 availability zones. And in many cases, actually new regions launched with 3, and in some cases, we actually have 6 availability zones. An availability zone is also not a data center. Availability zone is a collection of data centers. And availability zones are critical to be able to deliver highly available architectures for your customers, because an availability zone is actually isolated from another availability zone, so different power feeds, different cooling feeds, sometimes different floodplains if possible. But they're still close to each other, that they have single-digit millisecond latency. So that allows you to deploy, for example, a relational database, a master in one AZ, and a standby in another AZ, and you could do synchronous replication. So we always encourage customers to use multiple availability zones. Now, you could take your VPC, let's say you have a /16 CIDR range. You could carve it up into different subnets. These subnets would be based on your network segmentation. So, for example, you could have a web subnet and a application or database subnet. You will see terminology like public subnets or private subnets. The way it works is if a VPC wants to talk, let's say, egress out to the internet, you could do that, but you need to construct an internet gateway and attach it to your VPC. Now, that itself is not enough. You also have to have a routing table within your subnet that will allow that traffic to traverse to the internet. And of course, your resources in a public subnet, for example, would have public IP addresses. And those public IP addresses could be elastic IP addresses that don't change over time. Now, if you have private resources that need to talk to the internet, that's also possible. But usually what you would do is use something like a NAT gateway, which is our managed NAT service, which will allow your private resource to also talk to the internet, but without exposing their private IP address. Now, this is all good, but what if you want to talk to AWS services, right? We have regional services that don't live inside a VPC. And a lot of our customers don't want to use the internet gateway to talk to those services. They want to have private connectivity to those services. So historically, several years ago, we launched VPC Endpoints, and VPC Endpoints allow you to connect to these regional services through a VPC Endpoint construct, which allows you to connect to those services without having to go through the internet. Now, historically, the VPC endpoint only supported two services, S3 and DynamoDB. In fact, that original VPC endpoint is actually called VPC Endpoint Gateway Type. And I'm going to talk a lot more about this because PrivateLink enables a new type of a VPC endpoint that supports a lot of other AWS services. Now, if you want to connect to your on-prem network, you have a virtual private gateway, a VGW, and then you have several choices. You could use VPN tunnel, or you could use Direct Connect. I'm not going to go into the details of Direct Connect. We have new constructs like a Direct Connect gateway. Definitely encourage you to attend some of the sessions on Direct Connect throughout this week if you're interested in that. But basically, you could have connectivity to on-prem over a private network, again, either through a VPN tunnel or Direct Connect, which is a dedicated link between your data center and an AWS region. Now, a lot of times, VPCs need to talk to other VPCs. So how do you do that? We have a construct called VPC peering, which allows you to peer two VPCs and create a network trust. These VPCs could be in the same account, or they could be in a different account. One account could initiate a request to peer, a second account could accept that request, and all of a sudden you have a network trust. It does require you to update your routing tables as well to be able to take advantage of VPC peering. But that VPC peering will allow you two VPCs to talk to each other without having to go through the internet gateway. Just last night, we announced Transit Gateway. So immediately our slides become obsolete. And the Transit Gateway is another way to connect your VPCs. I'm not going to go deep into that. Definitely encourage you to attend some of the sessions on Transit Gateway as well. What I want to do is I want to zoom in on two aspects of this chart. I want to zoom in on VPC endpoints, the legacy type or the gateway type, and VPC peering. So the VPC endpoint gateway type is, for customers that want to connect to S3 and DynamoDB in a private way without having to go through the internet gateway, that is definitely the preferred option. But again, only two services are supported. And a lot of our customers have asked for VPC endpoint for many other services. The gateway endpoints also do not enable native connectivity from on-prem networks. So let's say you have an on-prem storage backup solution and you want to use S3 as a backend, you can natively go through from on-prem through a VPC and use those VPC endpoints. It is possible to do that, but it requires you to actually stand up a proxy fleet inside your VPC with a load balancer, and that presents a whole bunch of challenges in terms of high availability, scalability, cost, and it requires customers to manage some additional infrastructure inside the VPC. The other big ask from our customers is how do we enable VPC endpoint services for our own services, right? VPC endpoint service gateway type is only available for S3 and DynamoDB, but customers wanted to have the same capability for their own services that they deploy. So that's one set of asks from our customers. The second aspect is around peering. Peering from day one was really designed to create a bidirectional trust between two networks. It was never really designed to have a trust relationship on a micro level between two microservices. And some customers had architectures where they want just one microservice to talk to another microservice, but they didn't want to have to create that whole network trust, right? So that was one big ask from our customers. The other thing is there are some limitations with VPC peering. 125 doesn't sound so much, but if you have many accounts, many VPCs, very quickly you could start bumping up against that limit. And especially if you're a service provider and you have dozens or hundreds of customers, you will quickly bump up against this limit. VPC peering also does not allow overlapping site ranges. And that also presents a challenge, right? Because that means that you need to have new network space for each of your VPCs that want to peer to each other. And especially if you are a service provider and you want to provide your services to hundreds or thousands of customers, you're not in control of their VPC peer, of their VPC site range. So that quickly becomes a challenge as well. So we took all that feedback from our customers, and a year ago, we launched AWS PrivateLink. What AWS PrivateLink allows you to do is to bring a service inside your VPC and also to your data center. It could natively be accessible from a data center without having to do any complex networking. The service owner simply exposes a service construct without having to expose any of the underlying networking, and you don't have to set up anything like routing rules or anything like that, which I'll show you in a minute. And connection is always initiated by the service consumer, which I'll show you that as well. So let's look at the key use cases for PrivateLink. The first use case is to enable VPC endpoints for a lot of AWS services. Instead of just having S3 and DynamoDB, in the last year, we added additional 18 services that now have VPC endpoints, including services like KMS, for example, EC2. And this list is going to continue to evolve. For our service teams, in order to create a VPC endpoint through the PrivateLink technology is much easier than the previous endpoint solution. So that's use case number one. Use case number two is now you could use the same scalable, highly available architecture to create a VPC endpoint for your own service. So you could deploy a service in your VPC, same account, different account, doesn't matter, and you could expose that, and then you could create a VPC endpoint to connect to that service. And the third use case is for our partners, right? Partners that want to deliver solutions to thousands, hundreds of our customers, and they want to be able to make it really scalable. PrivateLink allows them to do that as well. And these are the two use cases that you're going to hear from Barry and Corey, right? Barry's going to talk about the Vanguard use case in terms of their micro-account strategy, and Corey's going to talk about how they're using it to deliver BPipe for their customers. And as I mentioned, this solution works natively from on-prem. As long as you have connectivity from on-prem, either Direct Connect or VPN, recently we launched VPN support as well, you're able to use those same VPC endpoint services that are being used from within VPC from on-prem as well. No more proxy setups, no more complex infrastructure, simply use the VPC endpoint services right from your on-prem infrastructure. So let's go a little bit deeper. Let's talk about how this actually works underneath the hood. Whenever I talk about PrivateLink, I always want to think about it from two perspectives. There is a service provider, and then there's a service consumer. The service provider, and that's why I have two VPCs here, and by the way, these VPCs could be in the same account, or they could actually be in two different accounts, doesn't matter. The service provider, of course, starts by deploying their service. Their service could be running, let's say, on EC2 instances, it could be running on containers, doesn't really matter. And then what the service provider does is they create a network load balancer. And network load balancer is going to be key to this architecture, and I'll explain why on the next slide. Once they create a network load balancer, then they create something called an endpoint service, and that endpoint service allows them to explicitly identify which other AWS accounts are going to be able to discover that service. So you could actually specify another AWS account, you could actually specify principals in another account that will then be able to discover this VPC endpoint service. Once the service provider is done, the consumer could, of course, have their resources in their VPC, and then they could create a VPC endpoint, the interface type, the new one that's powered by PrivateLink, to directly connect to the service of the provider. Now, the way they connect is when you create a VPC endpoint with PrivateLink, you get a DNS endpoint, and you use that DNS endpoint to connect to that service. Now, if you don't want to use the standard DNS endpoint service name, which could be a little kludgy, you could actually create your own custom DNS endpoint using Route 53, and Barry's actually going to talk about how they're doing that at Vanguard. Let's go one more step further. I have the provider VPC and a consumer VPC. I'm just zooming in and want to show you how the underlying technology is actually working. Now, you'll note these two VPCs have overlapping side ranges. That's no problem. Unlike with peering, where that would be an issue, with PrivateLink, the two VPCs could have the same exact side range. On the provider side, I have a couple of private subnets. On the consumer side, I have a couple of private subnets and a public subnet. Public subnet has a route to the internet gateway. So we start with the provider. The provider deploys their service on, let's say, in this case, EC2 instances. And then, as I mentioned before, what they do is they put a network load balancer in front of that service. Now, network load balancer here is key, because if you are familiar, network load balancers, the way they work underneath the hood is they will deploy an ENI, a network interface, into each of the subnets that's associated with your network load balancer. So in this case, let's say I associated my network load balancer with two subnets. I'm going to get an ENI, an elastic network interface, in each one of those subnets with a private IP address, and that private IP address will never change for the life of that network load balancer. And that's key to the solution, which you'll see in a second. So the provider is done. The provider then creates a service endpoint, identifies what other accounts could discover this service. On the consumer side, we create a VPC endpoint. You simply go to your console, go to VPC endpoints, choose the interface type, and PrivateLink here takes over, and what PrivateLink does is it will drop a pair of ENIs, or a single ENI, for each of the subnets corresponding to where the provider service is located. So in this case, on the left side, you could see that now we have two ENIs that PrivateLink deployed, one in each of the subnets of the consumer. And what it does is it creates a direct mapping between the ENIs in the consumer VPC to the ENIs of the network load balancer in the provider VPC. And this magic, this direct mapping, is really the PrivateLink technology. And you no longer need to have VPC peering. And now, all the resources inside the VPC that are able to connect to that ENI, right, from a routing perspective, everything is set up because you have the local route within each VPC. So routing perspective, you don't have to make any changes. You have full control of the security groups on these ENIs, which is important. So you can restrict which resources in your VPC could talk to these ENIs by simply managing the security groups that are associated with these ENIs. Now, this is a really interesting use case in that the backend resources on the provider side don't have to be actually inside the VPC. Network Load Balancer allows you to load balance traffic to your servers on-prem. So in this example, on the right side, you can see here I have my corporate data center, and I have a couple of servers. And what I could do is I could deploy, as a provider, a Network Load Balancer in my provider VPC, and with a target of an IP address instead of an EC2 instance. And this PrivateLink connectivity is going to work just the same if the backends were inside my VPC. So this is really powerful in that if you have data center services and you want to connect to them, you could use the same PrivateLink technology to connect to those resources that you would if they were inside a VPC. And Barry's actually going to talk more about it, how they're doing this at Vanguard. I want to also show you an example of an AWS service. So I just picked KMS because KMS was one of the first services that enabled VPC endpoints interface type. And in this case, because it's a managed service, it's our key management service, I don't have a lot of the details of the provider VPC because it's a fully managed service, so that's kind of abstracted for you. But what the KMS service did is they created a VPC endpoint service that allows you to then create VPC endpoints to connect to KMS. Now, when you create a VPC endpoint on the consumer side, what actually happens is you don't just get one DNS entry. You get multiple DNS entries. You get one DNS entry per AZ. You also get a regional DNS entry, which covers all of the AZs. And for AWS services, there's a nice feature where you can enable what's called private DNS. If you enable the private DNS feature, then the standard regional endpoint name, so in this case, kms.useast1.amazonaws.com, will resolve automatically to your private IP addresses inside your VPC as long as you're using the VPC DNS servers. So what that allows you to do is that when you're using VPC endpoint services for AWS services, you don't have to change your application code. You could use our SDKs, our APIs, the CLIs, and they will automatically route that traffic to the private IP addresses. So that's an option that's available for AWS services as well. Okay. Big question that the big question that's often asked is, what do I choose, peering or PrivateLink? Is PrivateLink a replacement for peering? And I hate to say this, but unfortunately it depends. It really depends on your use case, and it depends on the delivery model of how you want to deliver your services. If you have many services in VPCs that need to talk to each other, and you really need to create a network trust, then VPC peering makes sense. But remember, with VPC peering, you're really connecting networks, right? Don't think about connecting services. It's really network-based trust. If you want to do inter-region connectivity, VPC peering supports inter-region connectivity natively as well. PrivateLink is great if you have microservices architectures where you want to have fine-grained control between which services could talk to each other. And you always want to think about service providers and consumers instead of networks. And PrivateLink is also scalable to hundreds and even thousands of consumers because especially for use cases where you're like a service provider, right? And Corey's going to talk a lot about this from a Bloomberg perspective. If you're trying to deploy your service to support thousands of customers, you have no control over their CIDR range. And because you can't have overlapping CIDR ranges, right, PrivateLink may be just the best option from a scalability perspective. Now, we do need to update the slide with a new transit gateway, because transit gateway does address some of the limitations, but the main constructs are the same. Transit gateway is still all about networking and network connectivity versus PrivateLink, which is more about service-to-service connectivity. The other thing I will mention is you should also take into account the operational aspects of PrivateLink and operational benefits, because when you're creating a VPC peering connection, almost always you're creating a dependency on other teams. You're probably going to need to involve your networking teams, your telco teams, engineering, and a lot of times for enterprise customers, it could take days, weeks, sometimes months to set up that peering relationship because you have so many dependencies on different teams. With PrivateLink, because you're not changing routing tables, because you're not changing the overall network construct, sometimes you could get a lot more agility and do things much quicker without having to rely on other teams. And Barry's going to touch upon that as well. So just some of the key benefits. Again, PrivateLink is enabling us to connect to AWS services or your enterprise services or partner services with private IP addresses without having to go to the internet using the AWS backbone. It supports overlapping IP addresses, so you don't have to worry about CIDR ranges, you don't have to worry about running out of IP spaces and things like that. Connection is always initiated by the service consumer, so keep that in mind in terms of the different workloads that you may have. It supports natively connectivity from on-prem. As long as you have Direct Connect or VPN, you're able to use those VPC endpoints from on-prem network as well. And from an AWS perspective, more and more services over time will onboard to PrivateLink and use that as a way to deliver VPC endpoints. With that, I'm going to pass it over to Barry, who's going to talk about Vanguard's use of PrivateLink in their micro-account architecture.
Thank you, Ilya. So, as he mentioned, my name is Barry Sheward. I'm the Chief Enterprise Architect at Vanguard. I've been at Vanguard nearly 4 years now. I work in a team known as the Cloud Construction Team within the CTO office. And I'm here to talk about our macro account architecture that was developed by Matt Lanza, Glenn McBride, and myself based on some experiences that we had. So first of all, do we have any Vanguard customers in the audience? Great. Great to see. For those of you that aren't familiar with Vanguard, we're a very large financial services company, one of the largest in the world. We're a little bit different from the others in that when you invest with Vanguard, you effectively become part owner of the company, so there's no external owners. And because we're a large financial, should tell you two things. Firstly, we take security very seriously, and also we're very highly regulated. So that's important as we go through this deck. That's some of the reasons why you see some of the decisions that we've made. So we were founded in 1975 in Valley Forge, Pennsylvania, and our headquarters is still in Malvern, Pennsylvania. And when you think about it, 40 years ago, our founders thought to put us almost exactly between Wall Street and US East 1. We have several lines of business. They effectively work as silos. Retail is where you can buy your 401ks, and for those of you not from the US, that's like a pension. Institutional, I got those the wrong way around. Retail, anyone can buy mutual funds. Institutional is like pensions, 401ks. We have financial advisory services and international as well. So we started on our cloud journey back in 2016. At the beginning, we had a single account. Very few people had access to it, and it was fantastic. And it was fantastic because we had unregulated access to the internet. And anyone here work for a regulated industry? Yeah. So you realize, right, trying to get something from the internet or access to the internet, it's a tough problem. We were really happy, but the CTO came to us and said, look, other people want to build in the cloud as well. How are we going to enable a structure that can enable all these different users to build what they need to in the cloud? So we went back, and we had some people on one side saying one big account would be nice and easy to manage. And we had other people saying we should have account for every person and every team, right? Very difficult to manage, much lower blast radius. We compromised. We said that we will build an account for every line of business. So what you see on the left here, there would actually be multiples there. And we gave access to the internet over to our network access control team. And we built a peering relationship between those. But we still couldn't actually do any real work without access to on-prem. So this slide shows the Direct Connect gateway, but obviously that didn't exist back in those days, but we built direct connections back to on-prem. And there's the connections going into the line of business accounts and the network access control account. We still couldn't do very much. We were missing things like network time protocol, DNS, LDAP, Active Directory, that were things that were all provided by our data center services teams on-prem. So we built an account for them and set up the peering relationships and gave them a connection back to the on-prem network. And then finally, there's a bunch of shared services that were provided by yet another team. So we set those up in their own account and built all the peering relationships. And that worked really well. We could see that being a nice compromise between huge account and multiple accounts. Although again, on the far left, that line of business, there would be multiples there. And we replicated that, not just in our dev sys level, but also in our test and prod sys levels. So that spaghetti is what we have now. We lived with that for a while, 2 years in some experience. It was a great model, as Ilya mentioned, for a delivery shop. You produce software, you install it, you run it. But the company, we want to try and move towards a service delivery model, right? Have teams develop things, own them, lean, agile, that kind of thing. The issues with 2016 approach, first of all, the team that created the accounts did it manually, and it was a separate team. A lot of friction there. It took a while to get these accounts stood up. Once we had the accounts, the bare bone accounts, we actually had to provision the infrastructure inside it. We had a build pipeline to do it, but the configuration required to create the appropriate CIDR address ranges, the subnets within those, took a lot of configuration, right? So although it was an automated step, it took a lot of manual configuration up front. We also had inconsistency. So some of the accounts were slightly different from the others. The internet gateway is one example here. And also we had a big issue with IP address starvation. So for a company that's been around for so many years, in the beginning, we thought, hey, we've got more IP addresses than we can ever use. We very quickly went through those. And when you're faced with a situation where suddenly you're trying to use peering for VPCs and you can't have overlapping IP address ranges, you're kind of stuck, right? We also had network segmentation that said we want to see the following subnets and we want to see these kinds of things in them. So again, we're creating lots of subnets and wasting a lot of the IPs that we even had in the beginning. And then finally, because of this complexity, because we wanted our CloudFormation templates to work the same across multiple AWS accounts, we would create a whole bunch of Lambda functions to just do lookups of IP addresses and subnets and those kinds of things. We watched Amazon's announcements to see what they produced all the time. And there was a few things that when it all came together, we thought, this is what we need in order to start to move to a different model. The first one, AWS organizations. It was the thing that enabled us to move away from the manual provisioning of our accounts to a much more automated approach. It's an API call. The next thing was our CloudFormation stack sets. So instead of going through the process of doing a whole bunch of manual configuration and then having to kick off a step to actually build out the infrastructure within these accounts to support everything they needed to, now all we needed to do is add the account to a stack set and AWS would take care of it for us, right? I mean, compliance was a lot easier to maintain. EC2 Systems Manager was another. The ability not to have to worry about building all sorts of infrastructure to access our servers and just be able to do it through Systems Manager was another key benefit. And then finally, AWS PrivateLink. So all the others, the last three that we've seen, you know, they're nice. But it was the advent of PrivateLink that enabled us to be able to say, we don't have to worry about IP addressing at all. We can create all of our micro accounts to use exactly the same IP address range, have access to those through PrivateLink, and suddenly a whole bunch of the manual configuration and go into a network team and saying, hey, please can I have another 8 IP addresses? All that was gone, right? We had a solution where we could build something absolutely consistent every single time. So the first thing is, we went back to AWS organizations and said, how do we want to kind of structure these things in a way that would make sense? You start off with the root account in the root OU, and then we had a decision to make. Do we, from that point, focus on the breakdown, the hierarchy, on a line of business perspective, or on a sys-level perspective? And by sys-level, I mean engineering, dev, test, prod. Now, Vanguard, highly regulated. We are concerned more about a developer getting access to production data than we are someone from our retail organization getting access to institutional, right? So we went with the primary approach. We broke things down on a sys-level. You can see staging, development, and prod OUs here. Beneath that, we set up things at the line of business levels. So you can see here, line of business 1, obviously there would be a whole bunch of those. Enterprise shared services, network access control, and data center services. So that's the level that's set up from the division perspective. And then finally, beneath that, we set things up so that we could look at the account types. Micro accounts, macro accounts, and obviously one macro account typically per line of business. That's the legacy. And the new world is micro accounts that would all be created in that OU, all collected together. So what did that enable us to do? We had an STS-based identity provider that we could use. We developed it ourselves on-prem. And let's take an example of 3 separate users. We've got Alice. Alice works in production. She makes sure that the production systems are running. She has access to production. So she has access at that OU level to all the accounts within that OU. Bob is a line of business developer. He needs access to his line of business, and he has access to those 3 accounts. And then finally, we have Anand, who is Identity and Access Management Administrator, and they have access just to IAM capabilities, but across all the accounts by having access to the root OU. There's more on this tomorrow in another session about how we actually handled all the identity and access management within this micro accounts architecture. So we wanted to do a lot of automation to make this easy, and we wanted to provide a REST API so that we could completely offer this as a service, right? Trying to move towards the service-based approach at Vanguard. We created a component we called the Vanguard Cloud Registry Service, and we ran this in the root account. And I know that's a big no-no, right? You typically don't want to do that, billing account. The issue that we had is we needed to assume role into all these other accounts, and the only way to do it was really to put it there into the account that creates all the others and do the one-hop assume role into these other accounts. The VCRS worked across all sys levels, so it's one of the few things at Vanguard that actually can move across sys levels. Within a sys level, we would have a data center, and we would have a transit account. Within that transit account, the VCRS, when it starts up, would actually drop in a private link back to itself, right? So one of the interesting things about VCRS is if you run it by itself, no one can actually access it. So a lot of what VCRS does is provide connections back to itself so that other things can then make requests of it to add new capabilities. We then had our data center services exposed, and what you can see here is as VCRS is creating these, you can see them adding them to its own database. So we can see another one here, endpoint service 2, endpoint service 3. And what that enables other applications to do is query VCRS to say, hey, what services are available, and then be able to actually connect to them. So we're actually going to show that now. I'm going to show how VCRS steps through the process of how it would create 2 accounts, what it would do, and then how it would create a consumer and producer and build the relationship between them. So first thing we're going to do is create the account there. At the moment, you can see the blue line has created relationships to the data center services that are already on-prem. And basically, VCRS has a static list of services that everybody automatically gets access to. After that's done, VCRS then creates the relationship back to itself so that things running in that account can make requests from it. And we basically do the same thing again. The account on the left sets up, blue line points to the on-prem data center services, and then green line back to VCRS itself. So we have our two accounts. The account on the left is going to be the producer. So that spins up an EC2 instance, creates a network load balancer, and then it makes a call to VCRS saying, hey, I want to expose myself as a service. VCRS at that point will add that service to its list in the database, and you can see it's created a private link in the account. The account on the right then says, hey, I need to access that endpoint service. So what it will then do is make a request into VCRS, and you can see the yellow line there. It builds out the private link between them. So that's at a high level. We'll go into a little bit more detail there. We've got the provider and our consumer, and we can see that we've got our private link created on the left-hand side in the consumer. The first thing to bear in mind when we're talking about AWS accounts and account access and availability zones is that AZs don't map across accounts. So you can see here we've got AZA in the provider actually maps to AZB in consumer. The first thing that VCRS does when it creates the private link is it builds the whitelist. So it adds to the whitelist for the private link so that the AWS API will allow the connection to happen. The next thing is it creates the endpoints. And you can see here the endpoint creation. It is creating those links in the corresponding availability zones, not by ID, but actually under the covers within the same AZs. And that's the dotted green lines that you can see there. The next thing we do is set up Route 53 such that the consumer then has a record of how it can actually get to all those endpoints. So when the service provider decides to publish itself, it might be an enterprise DB service. It would say, hey, my Route 53 entry should be enterprise DB. And that will be the Route 53 entry that we create. So you can see here, though, that the problem is that our system on the right-hand side in our consumer, right at the top there, it needs to jump across AZs in order to actually connect to the service. That's completely possible, but it raises a question of availability, right? And we all want our services to be available. In this scenario, if the consumer's AZB failed for some reason, the service running in AZA suddenly is no longer able to access the service. So what we basically mandated is when you create a service, expose it across all AZs, right? So you can see here the yellow line here has been extended to AZD on the service provider side. So then under this scenario, VCRS would be creating an endpoint to AZA in the consumer, and the connection from the EC2 instance is no longer needs to travel across AZs. It can talk directly to the local AZ. So how do we actually access these micro accounts? We've effectively created a completely isolated network. So firstly, from a management perspective, obviously VCRS created the account. It has the role within that account. It can assume that role and perform any activities that it needs to. From a user perspective, we have a Bastion account set up. It has a few hard-coded user IDs. Our users are able to log into that, and from that, they can assume a role into the micro accounts so they can get in and do break glass work, solve problems, troubleshooting, that kind of thing. It's a very limited number of users. It's break glass situation only. It's typically used if our other mechanisms to access those accounts fail completely. And other mechanisms to access the account, we spoke about it briefly. For most other users, they would be logging into the identity provider system that grabs a role for them and then enables them to assume the role into that account. And then if they need to access specific systems within that account, they can do so through the EC2 Systems Manager. So that's how we enable access to those micro accounts. Future vision. So in terms of where Vanguard's going, the first is we've been looking at this and thinking, hey, now we have this ability to spin up accounts, on a whim almost. Are there particular use cases that would be really useful? The first is ephemeral accounts. So, this is a future. It's not available at the moment. It takes this concept of the 3 R's of enterprise security: rotate, repave, and repair. And that was typically applied to servers, and it meant, take one server out of the equation, spin up another one, make sure that it's patched up to date. And by continually doing this, if an attacker does manage to gain a foothold on a system, they don't have it for very long before that server gets wiped away and a new one gets created in its place. The attacker has to start all over again. And what we're trying to do is enable the same kind of capability for accounts. For some of these accounts, we think that we can actually provide zero access, no access to them at all from outside. And again, the smaller the attack surface, the more secure that the system is. So that's ephemeral accounts. There's also fit-for-purpose accounts. So we still do have the situation where particular organizations might say that, we've seen this with third parties, we will manage your VPC for you. Well, we don't really like that. Again, highly regulated, want everything to be secure. So this enables us to say, if you have a specific need for an account that needs to be set up in a particular way, we can use the mechanisms that we've built in VCRS in order to enable that, and we can build a fit-for-purpose account designed precisely for that use case and have VCRS be able to manage it, being able to create the services that are needed by that third-party piece of software. And again, we're using CloudFormation under the covers to enable both these capabilities. So I hope I'm leaving you here with an idea of the kinds of things that you can do with PrivateLink. We've used it to solve manageability issues, IP address issues, and there's no reason why you couldn't do the same. Apart from a VCRS, which is kind of custom logic, the workflows and everything is available through VCRS. So thank you, and I'm now going to pass you on to Corey Albert from Bloomberg.
Great, thank you, Barry. Before I begin, I just really want to say how grateful I am to have had an opportunity to work with both Ilya and Barry on this project and preparing for this project. They're just true professionals, and I've learned so much from them. However, that's not why I'm grateful. I'm grateful because their 2 presentations for the last, I would say, 45 minutes provided you guys with enough technical credibility to give this a 300-level course so I can get up here for the last 16 minutes or so and essentially mask a shameless product pitch for a brand new launch for BPipe, our flagship market data feed, in something that we're going to call a technical use case. It's brilliant. It's really good. So like we've exhausted, my name is Corey Albert, and I'm the head of cloud strategy for our enterprise data products at Bloomberg. So you might be asking, okay, what are Bloomberg's enterprise data products, or what is an enterprise data product? At Bloomberg, that essentially means that we take a bunch of information from a lot of different sources, and we take a bunch of information from a lot of different sources on anything that is tradable or a corporate entity. So think of things like pricing data, or reference type information that allows you to set up a security, or even things like news. In today's day and age, Twitter. We also do analytics like news sentiment analysis and provide our own earnings estimates, so some kind of predictive analytics there. So very exciting stuff. And regardless of that entire product suite, we kind of build our solutions on 3 basic principles. One, we want to make sure that the data itself is the most comprehensive has the most comprehensive depth and breadth of any data set in the industry. 2, we want to make sure that that data is delivered in a highly lightweight fashion, so it's easy for our customers' applications to consume that data. And lastly, we want to make sure that data set is clean and tidy so that it's analysis ready by both humans and applications. Now with today's product, I'm going to discuss BPipe, which is our flagship real-time market data feed. Now just by a quick show of hands, how many people here are in the capital markets or in the financial industries? Okay, great. So a lot of you already know what a real-time consolidated market data feed is. So what BPipe does is it really ingests data from all different sources all around the world. It normalizes that data, distributes that data, and it makes it available to applications via a common API. It sounds simple, but it's actually quite difficult, and it's quite difficult for two reasons. Oh, my nut. Sorry about that. I'm not. Here we go. Now we're going. It's really quite difficult for two reasons. The first reason is the sheer volumes of data, right? Last week, the markets have been kind of going crazy. And if you just take a look at just Amazon itself, ticker symbol, it updated last week, I think one day on a high volume day, it updated 375,000 times. So the price of Amazon updated 375,000 times in one trading period. That's about 7 hours, right? So that's about 15 times per second. So when you consider that across all the instruments in the marketplace today, which is about 35 million, that's a lot of data. And the other problem is that we have to get that data to our customers' applications very, very quickly. So when you talk about real-time consolidated market data feeds, you can't really not address something called latency, which is the time it takes from an exchange to tick out a price to the time it takes to get to an application. And in our world, despite all this volumes of data, that is measured in milliseconds. So it's a lot of data, have to do it really fast. So I work for Bloomberg, so I'm obviously biased, but I wouldn't say it's a good business to get into if you haven't started anything. So who uses consolidated market data feeds? It's really capital markets professionals from small hedge funds to global international banks. And traditionally, and they use them in front office applications mostly. And these front office applications do things like manage risk. They do automated trading sometimes. They manage portfolios. And more often, they just do things to allow professionals to make informed financial decisions quickly. And what drives these customers' buying decisions? It's kind of the same thing that drives any CTO's technical buying decisions, regardless of industry, right? You want a low total cost of ownership. People are okay with paying for data and BPipe service charges for that data, but they don't want to pay a lot of money to run that data. They want to pay a lot of money for infrastructure to run that data. Trust. People want to manage service. And in our world, in Bloomberg's world, that managed service comes with highly specialized support. Right? So they want to make sure that they have an insight into the data delivery path, and if something's going to happen that disrupts that data delivery path because they are making such high intensity informed trading decisions, that we alert them proactively. Lastly, they care about what I would like to call the ilities: reliability, scalability, and flexibility. These are obviously, if you're making trading decisions, and if someone's making trading decisions on your behalf, you want to make sure that their systems for managing orders, managing trades are up in the .999s and better. Scalability. Every small hedge fund has dreams of being a big hedge fund, so we want to make sure that our solutions can scale with them. And lastly, flexibility. Right? Up here, we're talking about the cloud. We're talking about a bunch of worlds of changes, and they want to make sure that our data solutions can adapt to those changing technology environments. And ironically, these are a lot of the same, I would say, ilities or the same decision makers that are driving people to move to the cloud. So, a question that you might want to ask is, why haven't financial industry firms adopted these front office applications in the cloud? Right? Barry talked about how Vanguard uses in the cloud. So financial services firms, capital markets firms, they're not scared of the cloud, and they're clearly adopting it. Oftentimes from hedge funds, it's for analytics, for quantitative data analysts. But we haven't seen that adoption yet in the front office application, these front office risk systems, these trading systems. And I think a lot of that is actually geared towards the fact that we haven't had a truly optimized market data solution to this point in time. Right? So you go back to, say, pre-2017, and what were firms doing? Firms wanted to be in the cloud. They wanted the advantages that the cloud provided, so they're moving their applications to the cloud. So in order to do that, they were taking market data from places like Bloomberg, paying for dedicated circuits, some 1 gig, 10 gig, these are serious circuits, ingesting that into their on-premises applications where they're hosting applications and servers and routers, only to publish that data back up to applications residing in the cloud. We just talked about latency. How inefficient is that? It's a double hop. You don't want to have a double hop. So firms like Bloomberg, I would say in June of 2017, we started to launch what I think in the industry has been called zero-footprint solutions. So what this does is it gives applications direct access to market data. And what happens in these solutions is firms like Bloomberg tend to host all that infrastructure. Right? So we have all that market data. We tend to host all that infrastructure. And if you have an application that's built towards an API, that application could reside in the cloud or anywhere, quite frankly, and connect up to a provider like Bloomberg via the internet and receive market data. That's good, right? It provides you fast access. You've gotten rid of the hosting problem. But we just talked about how important reliability was, and I just said internet. So not quite an optimized solution. However, today, I think we're introducing the first truly optimized solution for the cloud with Bloomberg BPipe leveraging AWS PrivateLink. So before I show you all the architecture stuff, let's just talk about the requirements for an optimized data solution. It must be a no-compromise offering. That's what our clients tell us. Right? And what do we mean by no compromise? It means they want the same depth and breadth of content that has been made available on on-premises solutions, regardless of where their applications reside. They want to ensure that we can deliver the same volumes of data, regardless of whether their applications are running on massive machines, on-prem, or in the cloud. Right? I just talked about how AWS updates 15 times a second. Well, you shouldn't have to not have AWS update 15 times per second in your application just because your application is running in the cloud. Right? So in our industry, it's called conflation. And we want to make sure that when we're offering a solution in the cloud, that was a non-conflated solution. Resiliency. Resiliency is obviously very important to our clients. And latency I've talked about. Latency measured in the microseconds and predictable latency in the cloud. It's very important. When we did our testing with AWS PrivateLink, we did exhaustive testings on predictive latency analysis and ensuring that it matched up with a latency analysis profile of what we do on-prem, or a solution that would have been deployed on-prem. We must continue to offer as a managed solution, right? You don't want to move. I talked about Bloomberg having expertise, so you don't want to move to the cloud and lose that ability to manage with expertise. So leverage the same monitoring solutions to talk about the health of the data delivery today. Our customers continue to want us to provide software updates for those BPipe processes and those BPipe market data services that we make available in the cloud. And lastly, anytime you talk about any kind of data, entitlement management has to come into play. And they wanted to ensure that their applications could use the same tools that they do today to entitle data, whether they're running on-prem, hosted, or in the cloud. And lastly, which is something that shouldn't be overlooked, is API consistency. Right? You should be able to use the same API to access data regardless of where your application resides. So this is the first diagram. When we talked about Bloomberg and getting our data into applications running in the cloud, it's kind of two parts, right? We wanted to make sure that we could efficiently get our data into AWS, and then once our data was there, ensure that it was very easy to access. And we kind of got lucky at Bloomberg, to tell you the truth, right? In essence, we're able to do this because we have a global network with a presence in 110 countries globally. So that makes it very easy for us to ingest data. And we're able to transfer that data from EMEA to Asia-Pac to New York very seamlessly with high resiliency. The other reason we got lucky at Bloomberg is that a lot of times vendors will do this using non-TCP connections, right? At Bloomberg, we do that, right? Our endpoint connections are all TCP IP based. Which is key. Not over our backbone. We do use multicast across our backbone, but the endpoint of the client is TCP based, which is great for us. So it allows us to quickly get data all over the world, but that endpoint can easily happen into the cloud with existing technology. We don't have to really refactor anything there. The key architectural decision that we did have to make when offering this service is whether or not we should offer this service in a Bloomberg managed VPC. Quite frankly, it costs us more money. It's a bigger spend for Bloomberg with AWS to do this, right? We want to host all of these BPipe services in our own VPC. It allows us to manage it, and it makes it easier for customers. So we took on that cost to make that happen for that manageability and that ease of connectivity for our clients. I think that was a great decision. So it's truly a market data service in the cloud. So if we go into more detail in the architecture, and I have the luxury of kind of glossing over at least a couple of different points. But what do we do, right? Bloomberg has, and this is just for, this is an example for US East 1. I only mentioned 2 availability zones, although there are 6 availability zones, but I'm not as good as Barry with my PowerPoints, so I have to keep it simple. So what did we do, right? First thing we did is we ran 10 gig direct connects from our data centers in New York and New Jersey to US East 1 in this example. And we deployed a couple of different software processes on AWS EC2 instances. One is something at Bloomberg that we call an AFN. It stands for Area Fan Out Node. So what does that allow us to do? Anytime you're dealing with market data or just distributing data in general, it's always expensive to distribute data or large amounts of data across firewalls. So you kind of want to do it once and then fan it out once you're in a trusted place. And that's what that software allows us to do, right? That allows us to send the stock price. If a customer of ours subscribes to Amazon, we could send that data from Bloomberg into the cloud once and then distribute it to all the customers that have subscribed to Amazon as a stock. The next piece of software that we deployed in the cloud was our bpipe software processes. And that's what does things like distribution for that real-time market data on a per-client basis. It also does things like a last value cache, but that's more technical on the market data side than a networking discussion here. Much like Vanguard did, we deployed an NLB and we provision those NLBs and we allow our clients to connect to those NLBs. Our customers set up VPC endpoints and their applications can reside in their VPC as well. Like Vanguard does internally, we've seen a lot of our trial customers also set up Route 53 instances just to make it, just to have that DNS name more readable for their end users and developers. The availability zones provide us with the resiliency that's needed for handling market data. Okay, so why did we select PrivateLink? It's really for the same reasons that Vanguard did and that Ilya presented earlier in the conversation. It's secure, reliable connectivity. It solves for overlapping address issues, right? I'm the head of strategy. I'm not the CTO. My goal is to pitch solutions like this so we get a lot of customers. So if we were using something where we could have IP address exhaustion, we couldn't gain tons of customers, which is our goal with this product. Something that we kind of learned through working sessions is actually how quickly the use of AWS in general and PrivateLink was to just provision a client, right? When we talk about, only a year ago, if you were taking a solution, you were taking on Bloomberg hardware and running connectivity and establishing that so that you can achieve these kind of fan-out benefits on-prem, it could take 6 to 8 weeks easily upon signing a contract before your developers can start coding. That's ridiculous, right? You have a project idea, you sign a contract, but until you can actually deploy all this stuff, it's a 6-week lag time. That's a lot of planning for clients, especially clients that are excited to get going. Especially think about a new hedge fund that just wants to start trading. They got their market data feed, they got their contract, they probably chose a vendor to do things like portfolio management. They have that time. What we've seen with the AWS solution, the time it takes us just to, spin up the EC2 instances, install our kind of standard Linux processes, install bpipe, and then make our bpipe service available via VPC endpoints. It's taken that 6 to 8 weeks with the same kind of reliable connectivity down to hours. So we have early adopter customers. They call us up, they sign a contract, and they're up and running that same day with a reliable with a reliable service. It's very impressive. Getting towards the end here. Just so people don't think I was here just chatting away and pitching a product, here are some tangible results from the lab. So this is real, this is running. The 2 major tests that we performed in-house, one was latency. And what we've seen is that the latency in the cloud is essentially the same latency profile that you would expect for an on-prem solution, but without all the headache of hosting services. It's as simple as that. The next thing that we wanted to make sure that we tested was we wanted to ensure that customers can seamlessly fail over. So if something happened to an EC2 instance and we lost the bpipe software process, today our SDK handles failover for our clients because they're highly reliable systems. We wanted to make sure that could still work in the cloud. And both tests passed with flying colors for us and our early adopter clients. Okay, so what's up next? I have a minute left. From a business perspective, Right, I mentioned early adopters. We're working with a handful of early adopters currently. We're going to ramp that up throughout the remainder of this year to probably 10 to 12 early adopters. We're going to continue to prepare, most likely on the more on the operational side, for a launch in early 2019. And then we're going to get, I talked about US East 1. We're going to continue to expand that solution globally. From a technology perspective, which is some of the things I'm most excited about, is we're going to kind of develop and test some multi-tenant solutions for customers that want to do development. Right now, we're hosting EC2 instances on behalf of the single customer. We think we could, we can gain some efficiencies by allowing a multi-tenant model. Taking advantage of some of the inherent AWS services for auto scaling and load balancing. And lastly, use serverless compute to do things like subscription management. And that's all I have for today. So on behalf of everybody, thank you very much for coming.